So this is my video for Lab 2, Lines of Charge. And this is my introduction slide. And this lab expands on the concepts learned in our previous lab. So Lab 1 showed us how charges interact in household items, like tape. And in this lab, however, the tapes are being analyzed as line charges instead of us looking at how the charges interact within them. So some concepts that are important in this lab are Newton's second law of motion, force equals mass times acceleration, charge interactions, Coulomb's law with electric fields, so force equals K, Q1, Q2 over R squared, and electric forces, and the equation is below. And this is my Lab 1 data. So in Lab 1, the tapes were treated as point charges, so the charges were centralized instead of spread out, So the distance that I had in Lab 1 was 0.072 meters. The length that I had of the tape was 0.2 meters. The mass of the tape was 0.0002 kilograms. The magnitude of the electric force was 1.962 times 10 to the negative 3 newtons. And the charge on the tape was 3.36 times 10 to the negative 8 coulombs. So in Lab 2, the same data was used, but instead of treating the tapes as point charges, we analyze them as line charges. This is the first part of my code. So the first part is just all of the measurement stuff. The second part is finding the electric field. Third part is you're treating it as a line charge, and that's creating the graphic. Basically, is the rest of that. It's creating the graphic that's shown. This is the second part of my code, which is continuing to create the graphic that's shown in the results, and it will return the magnitude of the electric force, magnitude of the gravitational force, how many electrons there are in the tape, finding the tape area and the ratio, and finding the ratio of number of electrons to total atoms. So that's all that does. So that's basically my entire code. And these are my results. So the red charge line represents the top tape. I know it's hard to see, but it's there. The blue charge line represents the bottom tape. The green arrows are the electric fields. The white arrow is the electric force, and the yellow arrow is the gravitational force. And the results that I got were the magnitude of electric force is 1.926 times 10 to the negative 3. The magnitude of gravitational force that I got was 1.962 times 10 to the negative 3. There are 3.03 times 10 to the 11th electrons on the tape, and the ratio of number of electrons to total atoms was 3.97 times 10 to the negative 7th. So, and now comparing the labs. So these were the difference in the results. For the magnitude of Q was lower in Lab 2, and the magnitude of Q was 1.93 times 10 to the negative 3 coulombs, as opposed to in Lab 1, it was 1.962 times 10 to the negative 3. There are more excess electrons in Lab 2 results as opposed to Lab 1. The electron to atom ratio in Lab 2 is also bigger, bigger than it was in Lab 1. The magnitude of the electric force is roughly the same, and the magnitude of the gravitational force is also roughly the same. So the conclusions: in this lab, when we treated the tapes as line charges instead of point charges, the value for Q of the top tape was larger. And The assumptions that were made were that the tapes had the same net charge, ignoring air resistance, and the charge is evenly distributed. And thank you for watching my video.